As you've read, our aim for today is that computers will be able to write parallel and perpendicular equations through a point. So we're going to be given an equation today, and graph. Don't forget the and graph part. Real focus though being the first part of that. We're going to be given equations today, and we're going to be told to graph a line that is parallel or perpendicular and goes through a certain point. So this is very similar to what we did 2 days ago, except instead of being given a y-intercept, we're given a point. So remember, we can't plug that point directly into our y equals mx plus b. So the first thing that we need to see is we need to write an equation that is parallel to y equals 3/5 x minus 4. What's going to be the slope of this equation that we are writing? If it is parallel to y equals 3/5 x minus 4, what is the slope going to be? If you don't engage your brains, this is going to take forever. If you do, you'll probably finish your homework during class today. Janelli, 3/5. So we need an equation that is y equals 3/5 x plus b. We have our point. Just like yesterday, we're going to plug that in to find out what b is. So 3 is equal to 3/5 times -5 plus b. This is a bad date. That's going to give me 3 is equal to -3 plus b. Add 3 to both sides. And that tells me that b is equal to 6. So my equation, and this is our whole point here, is y equals 3/5 x plus 6. And I want you to graph both lines below. So we're going to graph the original line, has a y-intercept of -4. A slope of rise 3, run 5. Rise 3, run 5. And this one has a slope of 6, or excuse me, a y-intercept of 6. 1, 2, 3, 4, 5, 6. Rise of 3, run of 5. I'm out of space doing this way, so I'm going to go back to our other point. I'm going to go backwards, down 3 and back 5. Then I'm going to get out my trusty straight edge, which, finder. I missed. I'm going to try again. Or I'm not going to try again. That line's going to have to stick.
Starting up to 6, going up 4, over 6.
And sure enough, our lines look like they are indeed parallel, which is what we were shooting for. All right? Pretty easy, considering if you could do what we did yesterday and do what we did 2 days ago. This is really just kind of combining those two ideas together. All right, so this one says to write the equation of a line that is perpendicular to y equals 1/2 x plus 2 and goes through 3, 6. So focus in here on the idea that this one is perpendicular. What is the slope of this line going to be that we need to write? We might need to show a quick touch of work. Raisa. -2/1. So she took our original slope, which was 1/2. She flipped it, found the reciprocal, and then she said, well, it was positive, now I need to make it negative. So we have y equals -2x plus b. Now we just need to sort out what b is. Just like yesterday, we're going to plug in our point. 6 is equal to -2 times 3 plus b. 6 is equal to -6 plus b. Add a positive 6 to both sides. Plus b. 12 is equal to B. So our equation should be y equals negative 2x plus 12. Now we need to graph both lines. The original one's going to be really easy to graph. Y-intercept of 2, rise 1, run 2. Rise 1, run 2. However, when we get to the second equation, that's going to be a little bit more difficult. Why is that going to be a little bit more difficult? Sarah? Yeah, it's not going to fit on there. But if we remember back to yesterday, if we have a slope and a point, we can graph it using that slope and point. So remember, we were told this line has this point, 3, 6. So we can go over to point 3, 6, over 3 and up. Can't count 6. 6. And we went back and we said it has what slope? Yeah, negative 2. So that's a rise of negative 2 and a run of 1. So it actually has this point in common with the other one. Get your straight edge. Draw my first line. And get my straight edge and draw my second line. Now it said they should be perpendicular, so how can I check to see if these are actually perpendicular? Yeah, but yes, they're still down there. So how can I check to see if this is indeed perpendicular? What can I do? Katie? Yeah, check to see if there's right angles in the middle. So that means taking the corner of a piece of paper or whatever you have that has a right angle and just lining that thing and oh, yep, that looks pretty right angle to me. All right. One last problem. This one says write an equation of a line that is perpendicular to y equals 3/2 x plus 2. Goes to the point 4, negative 6. What's the first thing that I should do? Michael. Yeah, so he's saying we need to find the slope of our new equation, and since it's perpendicular, we're taking 3/2. We're flipping it over, and it was a positive, so I need to switch it to a negative. So I know my equation is going to be y equals 2/3 x, negative 2/3 x, plus B. Now what? Javier. Plug in the y and the x. Way to catch your math language there. That was perfect. Equals 2/3 times 4 plus b. And it's going to give me negative 6 is equal to, this one's not going to come out so pretty, 8/3 plus b, and it's negative because it's a bad date. Janelli, now what? Add what? Add a positive 8/3 to both sides. And I need to find common denominators here for 8/3 plus 6/1, negative 6/1. So I'm going to multiply by 3/3. It's going to give me negative 18/3. Good date or bad date? Bad date. So that's going to subtract. That's going to give me 10/3 equals B. negative, take the sign of the larger number, Mr. Boots. So our equation is, I'm going to put it down here, y equals negative 2/3 x plus negative 10 over 3. So the first equation is going to be really easy to graph. 3/2 x plus 2.
What?
So y-intercept of 2, this is our original equation. Rise 3, run 2. Rise 3, run 2. I'm going to go ahead and use my straight edge for this one. And how do you want to graph this new equation? There's a couple different ways we can do it. Your choice. Rebecca? Okay, so she says she wants to use the given point rather than using the slope-intercept form of the equation. So I'm going to go to 4, negative 6. 4, negative 6. And the slope I can see up here is negative 2/3. So that's a rise of negative 2, run of 3. Rise of negative 2, run of 3.
Wait.
Oh, that's a total miss. Why does it do that? All right, we'll go with that then.
Oh, damn. How many times?
All right, so we can see that I missed a little bit here, so this one's not going to probably come out to be quite a perfect right angle on my perpendicular lines, but sure enough, I get in there and that's pretty close. All right, questions about our work for today? Since we have no questions, that means you should be able to very easily tell me the 2 key points for today. So as soon as you're ready, I will accept your key points. And they can't come from Rebecca or Javier or Memo. Michael. So Michael is in the middle of our first step here, our first thing that's really our key point. And he's saying we're talking about finding the slope of the new equation. So find the slope of the new equation.
Wait.
And he's specifically telling us parallel. Same slope. Perpendicular. Opposite. Reciprocal. So that's 2 things. It has to be the opposite and the reciprocal. Okay, so once we found the slope, then what? Second key point. Katie. Yeah, plug in x, y, and slope. X, y, and slope to find the y-intercept. Find the y-intercept. From there, you can plug it all into your equation and make your wonderful equation and graph. Questions about our work for today? Fantastico.